collision, tell me what can happen. Inelastic collision. After collision, what happen? After collision, what will happen means first what happen? What you should do is there are around some approximately 8 numericals are there based on this. So you must able to manage all that with the help of this concept. So this is M1. So how the initial velocity, it was having impulse will act like this, and the impulse here on the wedge like this, and it's having initial velocity u1. Tell me after collision, what can happen to the wedge? What are the possibilities for the wedge? And what are the possibilities for the ball? How the ball can move? The ball will have horizontal component, and I'm assuming vertical component. And what about the wedge? Wedge may continue to move, or may come to rest, or may what happen, rebound, because how the impulse J is acting towards left and ut is towards right. So possibility that the wedge what happen may move towards left after collision. Tell me what about the ball? Ball must have horizontal component v1x, no, because a component of impulse will act here. A component of impulse will act along x-axis. What about along y-axis? Along y-axis, v1y may be 0. When it will be 0? When j cos theta equal to m1u. So I'll write down the possible equations. So what are the first thing? Along in what direction the momentum is conserved? Let me clarify that also. Any direction or only one specific direction? Only along x-axis momentum is conserved. So how do you can say this? Because along line of impact, what is the problem? Along line of impact, what is the problem? Along line of impact, component of impulse by the ground on the wedge will be unbalanced along line of impact. Along y-axis, this is unbalanced. So therefore, momentum is not conserved along line of impact and along y-axis, only along x-axis. Can I conserve momentum? Yes, you can conserve momentum. So can we write equation like this? m2u2 equal to m2v2 plus m1v1x. This is a one equation. Then what all any other equations can we write? Impulse momentum equation I can write on the wedge also. m2u2 minus j sine theta on the ball, j sine theta equal to m1v1x. Then along y-axis, m1u1 minus j cos theta equal to v1y can be negative. Huh? So what are the possibilities? The ball can move like this after collision, means can move horizontally, and because of weight it will describe parabolic path. Can move like this also, because if impulse j cos theta, if it is greater than m1u1, then v1y will be upward. Then how the ball can rebound like this. So what are the possible path for the ball? I'll just show by color. So it can be like this. It can be like this. It can be like parabolic path, no, because of effect of gravity will be there. These are the possible path. What are the possible path for the wedge? It may come to rest. It will continue to move towards right, or it will rebound towards left. In all the cases, we can. So any, I think many unknowns are there, no? Can we apply quotient of restitution formula? Yes, you can apply quotient of restitution formula also. So what is the, this is the line of impact. I'll show it here. This is the line of impact. What are the velocities of the wedge? It is u2 and v2. What about the ball? Instead of messing up everything there, no? So you can v1x and v1y. Now, what can be this one? So this is the theta, no? And this will be theta. Now, define anything. This direction is positive. So then what is the formula? E is equal to V2 sine theta V2 sine theta. This will be theta. V1x sine theta minus V1y cos theta. From where I'm resolving this one. V1y sine theta will come towards negative direction. V1x sine theta will be towards right, along positive direction. V1y sine theta. This is theta 90. V1y cos theta will come. Yeah. So this should be the velocities of the wedge and that of particle along. So why two components is due to x component, due to y component. I'm resolving along line of impact here. Divided by that of the particle is having u1, so along minus u1 cos theta. This will be v2 sin theta. Like this, you can define coefficient of restitution based on the value of E. Yes, you can solve it. There's one more equation what we got it. If E equal to 1, then you can apply conservation of kinetic energy also. If E inelastic collision, then you take help of this equation. Means quotient of restitution in any case it is determined. So this is a generalized equation. Now if there is a friction between the wedge and the ground, then can you apply conservation of linear momentum? The answer is no, because impulsive friction will come into picture. So this is not valid. Can I write this equation? M2U2 minus J, then impulsive friction also you have to introduce here. This is valid. These two are valid. If the friction between the wedge and the ground, these two are valid. If there's a friction between the wedge and the ground is there, these two are not valid. This equation is valid irrespective of what all things. Quotient of which you can define it. If there's a friction between the ball and the wedge, then these equations are not valid because impulsive friction should come into picture. And the impulse will also act on the wedge. Then these two are not valid. So if there is a friction between the ball and the wedge, all four are asked to be modified. All four has to be modified here. Getting no? This one. So any arbitrary way, I think definitely more generalized discussion is very important rather than just I did one numerical. If just one numerical solve come out, you don't learn. I'll some screen stopped here. I'll get back. Able to see the screen?
Yes, sir.